Good day. I am Gerard Casiño
I am Loruelle Griño.
and for our Capstone project, we decided to create a program for calculating the volumes of a specific shape.
So, what is volume? Volume is the quantity of three-dimensional space enclosed by a closed surface. In most math or engineering scenarios, finding the volume of an object helps to determine the amount required to fill the objects. The, m- the most commonly used shapes are cuboids, cylinders, cones, spheres, and half spheres or hemispheres.
The programmer is meant to solve these statements. First is to help the user to solve a mathematical problem that involves in finding the volume of specific shape without the need to memorize or to recall the formulas needed. Next is to create a user-friendly interface and for the user to save time.
Objectives. This program aims to calculate the volumes of the most common shapes used in most engineering and mathematical problems. The program also aims to provide users the convenience of calculating the volume even without recalling the formula for the specific shape.
So for the flowchart of the program starts with introducing itself and asks the user shape with what shape he desires to calculate the volume. Then it will decide if the output if the input is within the specific parameter. If it is false, then it will display a message that the input is an error. Then it proceeds in asking the user if he wants to calculate another volume. If it is true, then it will proceed in deciding again if it is 1, 2, 3, 4, or 5, or 6. For example, the user chose 1. Then the program will ask the necessary data for the dimensions of the specific shape that user chose. So after that, it will perform the operation and display the output volume. The same process will be encountered if the user chose the other options from 2 to 6. So after displaying the output volume, the program then asks the user if he wishes to calculate another volume. If yes, then the program restarts, and if not, then the program terminates.
So, explanation of the program code.
In this program, we use the float to declare the variables for each shape. So for cube, we declare the variable a for its side, and for cuboid, it's lbh for its length, base, and height, and so on for other shapes. So we also use the dual to create a loop for the program. So if the user chose to in it is showed in the flowchart, if the user chose to create a loop, then the program will do it.
So, the program will ask for the user's input to choose which shape to calculate the volume for. Then at the if statement, if the user wants to calculate the volume of the cube and inputs 1, the program will then display a message asking for the value of the specific dimensions. In this case, the length of one of the cube's sides. Then it would store this value and proceeds to perform the operation. Then, finally, returning and displaying the volume of the said cube. It applies to the other shapes using the else if statement for a cuboid, 2, and so on and so forth. until it reaches the do while loop, which either repeats the process or terminates the program.
So for the program demonstration, we tested the accuracy of the program by solving it manually and solving it using the program.
So demo, and this for cube, if it's 1, side of the cube is 9. So for you calculate another volume, select cuboid, then enter details 15, 10, 12, you get the same value. For cylinder, dead air, radius is 5, height is 8, we get the same 628 cubic meters. For cone, radius is 9, height is 4, 339.12 cubic meters. For sphere, radius is 15, same. For hemispheres, radius is 3, 56.52 cubic meters. So you then terminate the program. So in conclusion, the volume calculator program saves the user time by just inputting the values that the program solved to solve for the volume. But the program is limited to 1 SI unit, which is only in meters. So outro.
That's all.
That's all. Thank you. Bye bye.